in chapter 2 right now on the study of matter and energy. And this chapter is all about the transfer, how energy is transferred in chemistry, then additionally scientific method kind of stuff. So we'll start with energy. Our traditional definition of energy is the capacity to do work, right, or generate light. And in chemistry class, the energy changes are associated with all changes in matter. So last chapter we talked a lot about how to tell if something was a chemical or physical change or not. And in this chapter, we're talking about how the energy changes in those different types of changes. And so in a physical change, your identity of the substance doesn't change, but in a chemical change, the identity of the substance does. So the chemical formula will change in a chemical change. The properties of the substances will change, and that is a key component of a chemical change as opposed to a physical change. But energy changes can be defined in two categories as well. Those two categories are endothermic and exothermic. So if the energy is leaving the system and going to the surroundings, then that is exothermic if it's exiting, and it's endothermic if it's coming into the system, right? And so some examples of endothermic processes where you have to put heat into the system are evaporation and melting, because in those processes you add heat, right? And then that increases the temperature and allows those processes to happen. Energy can be released in an exothermic reaction, and that is observed oftentimes as when a gas is condensing into a liquid, it has to release the heat energy that it had as a gas in order to get into the liquid phase. And so, what do you think is a good way to remember these terms? Think about it for a second. That's an important thing for you to be able to discern between endothermic and exothermic. And so if we're given this process, right, this is an illustration of the phase changes of water, right? So you have solid water over here on the left, and then when that heats up to the melting point, if heat is continuously added, then it melts, right, and forms the liquid phase. So when it goes from the solid phase to the liquid phase, we call that melting, and the reverse of that process is freezing. And then if you have a liquid and you continue to add heat and you get it up to the boiling point, then you can have the process called evaporation happen, where it turns from a liquid into a gas. And of course, then the opposite of that is called condensation. And then in certain situations, you can go straight from a solid to a gas, that's called sublimation. And then if you go straight from a gas to a solid, that is called deposition. And so all these processes, when you have energy changes, they must follow the law of conservation of energy. So energy cannot be created or destroyed in any chemical reaction, only changed in form. And so when the energy is changing in form, that's what you're observing, right? You're not observing energy being created or energy being destroyed. It's the energy is converting from one form to another. And then that's when you notice it, right? So you can get chemical energy from food, and that can drive your muscles, right? And so then you have chemical energy being eventually turned into kinetic energy there. So it's important when you're talking about energy transfer, you have to define your system and your surroundings. The system is the part of the experiment, part of a process that you're looking at. So that's what makes it the system. And then the surroundings are everything else, because the area around the system. And so when you have energy or matter flowing from your system to your surroundings, or your surroundings to your system, that has to follow the laws of conservation. And so if you have an exothermic reaction, you have that heat leaving the system and going to the surroundings. That's what makes it exothermic. And then in an endothermic reaction, you would have the opposite, right? The heat is going from the surroundings into the system. And so there's a bunch of different forms of energy, and you're going to work through some simulations that'll help you to get more familiar with those energy conversions. the energy changing forms from one to another.